Alrighty, welcome back everyone. So we are doing a leak code problem, giving ourselves just under an hour to solve it. And this one is called delete node in a linked list. We're going to use Python to try and solve it. This is not one I've done before, so you're going to get to watch me struggle. I'll try and talk through it as much as possible because I do want to replicate, doing this like in an interview environment. Also, to add some additional stress to make it seem a little more realistic, I don't have my air conditioning on. I noticed that that made me kind of antsy when I was doing a problem yesterday. It definitely stressed me out, just like being like kind of hot and clammy and whatever. So uh, initially I was thinking, oh, that's not really conducive, but then I realized actually that's kind of how it is in a real environment for an interview. Is you're nervous and you're sweating and you're just like it's hard to think sometimes. So trying to replicate that any way we can, I think, is actually helpful. So hopefully that factor will introduce some additional stress. All right. So this one's called delete node in a linked list. There is a singly linked list head. We want to delete a node in it. You are given the node to be deleted node. You will not be given access. This is in bold, so it's probably pretty important. To the first node of head. Okay, interesting. All of the values of the linked list are unique, and it is guaranteed that the given node is not the last node in the linked list. Okay. Delete the given node. Note that by deleting the node, we do not mean removing it from memory. We mean the value of the given node should not exist in the linked list. The number of nodes in the linked list should decrease by 1. All the values before node should be in the same order. All the values after node should be in the same order. Okay. So in Python, with like with a list, not a linked list, but just like a regular array type data structure, you can use pop and then pass in an index, and it'll remove the element. In this case, with a singly linked list, we're going to have to like traverse the entire linked list until we find that particular node, and then we're going to have to figure out how to remove it and basically take the node before it and the node after it and connect them. At least that's what my brain is telling me. Like, just having read this, we will find out if we're on the right track. For the input, you should provide the entire linked list head and the node to be given node. Node should not be the last node of the list and should be an actual node in the list. Okay. We will build the linked list and pass the node to your function. Your output will be the entire list after calling your function. Okay, so our function is going to take the entire linked list head and the node that we want to delete. And one of the parameters here, requirements, is that that node is not the last node and it should actually exist in the list, which is good. That means we're going to find it as we traverse through the list. So then they're saying we will build a linked list and pass the node to your function. Okay. The output will be the entire list after calling your function. So essentially our function will return the linked list sans the node that we were asked to remove. So here's an example. Here's a linked list. Head is 4. Head node is 4. Points to a node 5, points to a node 1, to a node 9, and then the input node is 5. And so then here the output is the head node is 4, now points to 1 instead of 5, and then points to 9. So again, here's an example input where the head is 4519. Oh, this is interesting. I guess what they're calling head is actually the entire linked list. For some reason, I would have thought that, I guess if you have the head, you have the entire list. So that makes sense. I was thinking like root node or something. Okay, so this entire thing, it's what they're calling head, and then node is 5, and then output is 419. The output that they're giving is in a list format. So it's weird. Inputs and outputs, we could test it in a second and see, just like hard coding to see what it really expects as output. I don't know if they truly want us to output a list. I would think they want us to output an actual linked list. It says the output will be the entire list after calling your function. So we'll see. All right. So the explanation for the input and output here with this, whatever you want to call this little diagram, is that you are given the second node with the value 5. The linked list should become 4 to 1 to 9 after calling your function. Here's another example. I think it's the same list, just a different node. So now instead of 419, it becomes 459 because the given node is 1. So 4519 node 1, 459. Okay, constraints. The number of nodes in the given list is in the range 2 to 1000. Okay, so there's going to be anywhere between 2 and 1000 nodes. And then the node value is greater than or equal to negative 1000, less than or equal to 1000. So that's interesting. The node value can be either a negative or a positive number, integer. The value of each node in the list is unique, so there's never going to be any duplicates. That's good to know. The node to be deleted is in the list and not a tail node. Okay, cool. So yeah, first things first. I don't know how they do the output or what they give us access to in terms of logging for debugging and whatnot. So we'll find out. Also, what is this little thing over here? I don't know. That must be some type of, I guess, note-taking in Markdown. Maybe that's an extension of mine. I don't know. All right, so we have a class called solution that has a method called delete node. This is the function that we're going to implement. The type node list node. So this argument here, node, is a type of list node. In the comments here, it's just saying like, hey, you also have access to this this class list node, which the dunder init method, constructor function, whatever you want to call it, is going to initialize or instantiate each instance of this list node class with a value set to whatever gets passed in, and then next set to none. Next, none would be if there's only one node, right? There's nothing to point to, or if it's the tail node. Once you get to the tail, it's going to point to none. Okay, so it's so hot outside. I'm already in my office. I'm already sweating with the AC off. So this is good. It's definitely something about like being hot and uncomfortable makes my mind like move more quickly, which makes it hard to focus, makes it easy to miss important details, and makes it easy to get like nervous and like buy into any like negative thoughts, once you start struggling and all of a sudden you're just like, oh my gosh, I don't know how to solve this, or whatever, little bunny trail your brain can go down. So this is good, in a bad way. All right, so the list node, like we said, has a val, has none. We're given an instance of list node. And then our type here, void, return type. Void, do not return anything, modify node in place instead. Interesting. Okay. So delete node. I thought they were giving us 2 arguments for the input. For the input, you should provide the entire linked list head and the node to be given node. Node should not be the last node of the list. So here, delete node. I don't know, man. Let's find out what self is equal to, if we even get access to the print output here. And then let's get access to node. All right, we're back. We're logged in. We should be able to run this now. Oh, they have a To use the debugger, you have to upgrade to premium. All right, well, there's other ways for us to debug our code, I suppose. So standard out here, solution object. If you noticed, I printed self and then I printed node. So just to be more explicit, we can say self and then node. I should probably stop using the mouse. So here we have self is this object, solution object, blah, blah, blah. And then node is this list node. Oh, check it out. Okay, so the val is 5, and then next list node is 1, and then 9, and then none. So 5, 1, 9. So this is interesting. The node here. Right. Okay, it's all coming clear to me now. So if their input are these two values, we're getting the 5, right? And then because it's a node, it points to the next until it gets to the end. So that's why we start at 5. Their input is 4519. We want to remove 5. We want to return 419. Again, I wanted to see what they expect as a return value. So just like we're just going to cheat here and say 419. I don't think they expect it as a list. If they do, that's going to be interesting. But that would essentially pass one test. Oh, right. Do not return anything. Modify node in place. So even though we returned something, we're already not paying attention to what it said. Don't return anything. It's just going to return none. So the node in place. This is interesting. So something else is already pointing to this node. And we need to like figure out how to remove the root or the head, whatever you want to call it. I don't know the exact syntax or naming convention, but we want to remove essentially the first node, if I'm not mistaken, so that, but then I don't know how we update the head or whatever they're calling it to now point to the next node. And this is a singly linked list, so there's only one direction that it's going. I'm a little confused. So we're going to do this. We're going to dismiss that. And we're going to do I don't know if this is going to work inside the print. We might need to make it separate, but I want to see what's a dir on self. All right, so self just has delete node. Okay. Interesting. Yeah, I'm a little confused. All right, let's do a dir on node. See what's available to us there. It should just be val and next, and then a bunch of built-in dunder methods. Of course, we want to print that. I'm just confused about what they said was input and then what's actually input. But then it also says we will build the linked list and pass the node to your function. So I'm not really sure how I would get access to it, or if I even can, or if I even need to. But all right, so we have next and we have val. Delete the node. I'm already confused, of course. So it's saying like, here's your given node 5, and then 5 points to 1, 5, and then 1 points to 9. And it's, I guess the linked list, already points to our node. So how do we change our node such that our node is no longer, look, we probably shouldn't just think out loud. We should probably type this stuff out. So we'll do a little multi-line comment here and start asking some questions. We'll say, how do we change node such that the root, we'll just call it root, first node no longer points to, or just say no longer exists. So I'm going to print node again. I do want to see what that looks like. All right, so it's a list node. It is this instance. And its value is 5. Its next value is another list node. So, oh, okay. Okay. I think so. So what if we did this? What if we took the value of the node that we're in and we changed it to the value of the node from next? And then we went to the next node and we changed its value to, we don't even really let's think about this. We're visually looking at 519. So in this exact instance, it makes sense for us to just say like change the value of 5 to 1 and then change next to what, not the next one, but the one after that. But there could potentially be any number of nodes in this linked list. So we can't just assume that like the last node is the one to the right, right? We essentially have to like iterate through each node and keep setting each node to the node to its right until we get to the very end. When we get to the end, the last node becomes none, if I'm not mistaken. So let's just try and keep our line of thinking here. We'll say assign val, let's go ahead and call it node.val to node.next.val. And then I would say iteratively, we might even do this with recursion. There is a base case here, right? One until next is none. Yeah, recursion might actually make more sense here. Or we could just break out of like a while loop until node.next is equal to none. So let's try that. So let's do something like while true. And if we're in Python, then true is actually a capital T. And to get into the code block, we need to put a colon at the end of the line. And we're going to say assign node.val. So currently we have node and we have node.val. And so we're going to say node.val is equal to node.next.val. So if we're looking at this here, basically this value 5 becomes 1. And then we have to say node.next is equal to, and we're probably going to need a condition here, node.next.next. So basically we're saying this current node's next was pointing to this next one, but we want to jump one to the right, unless node.next.next is none, in which case node.next, oh, you know what? I guess it won't matter, right? So all we need to know is that when node.next is, we'll say something like, now that we've done that, if node.next is equal to none, I guess we can say is none in Python, then, so we could even do, we're not going to optimize it right now, but we could do something like while node.next is not none or something like that for our loop. Then I think we can just break. And then at this point, fingers crossed, there's no way this is this simple. I highly doubt it. So let's go ahead and run it. Okay, well, this is interesting. One use case passed, and that's where it's 1. We got back 459. But in the case where it was 5, we got back 49. Oh, interesting. So okay, one of two things is happening here. Let's look at this other one and try to compare these two. So in the case where the input, they're both inputs are 4519, but it's just the node that changes. So when the node is 5, we're getting back 49, the first and the last. So we'll think about that in a second. When the node is 1, we're getting back 459. So 4, 5, 9. So in this case, it was saying like if it started at 1 let's go ahead and just print it here. Print the node, run it. We'll look at the second test case. It's so hot in here. Definitely adds an element of stress. I have some like classical music or whatever playing in the background, so in my earpiece, so that helps keep me calm. But yeah, the sweat is, or like the heat combination, heat sweat. It definitely like mildly emulates the interview process. The main thing with the interview is like, if you have a moment of silence where you're thinking, while you're trying to think, your brain is like, oh no, I've been quiet for too long. Like they think I don't know whatever, negative self-talk. And so that just exacerbates the situation. And then everything that you say out loud, like you're trying to communicate and like let the interviewer know what's going on in your head. And then you like, anytime you say something that you think is wrong, which is totally fine in a real world setting, in an interview, you're like, oh no, I'm supposed to know everything. Of course, nobody knows everything, but depending on how complex you determine, you think the problem is supposed to be, you may think like, oh, the expectation is that I know everything, and that's really not what people should be testing for. That's kind of what our brain wants to tell us that people are looking for, but really they're looking for like communication and problem solving and things like that. So, all right, back to the problem here. So if the node, again, this one starts at 1, and then the next is So if we say node.val, so 1 is equal to 9, and then node.next is equal to node.next.next. So node.next is equal to node.next. Oh, okay. How would that even work here? This node.next is this node. Nope, it does work. Okay. So node.next evaluates to this one, and if you call .next again, then it's none. So then you say, hey, is it none? Break out of here, we're done. And so the result is that this node now is equal to 9. So then 4 and 5 are going to point to 9 because you've essentially removed 1. So I thought that would be the same situation here. 5, 1, 9. So if we're saying node.val is equal to node.next.val, which is 1. So 5 is supposed to become 1. And then node.next is equal to node.next.next. So if this is node.next, the next of the one that we've turned to 1 is now pointing to this. Okay. And then we say if node.next is equal to none, this is where things might get crazy, because node.next currently is not equal to none. So then it goes to the next one, and it says node.val is equal to node.next.val. But like now that we've done this, the next node should be this one. If you say node.val, which is 9, is equal to node.next.val, there is no .val in that next one. It should have broken. So technically this needs to be something like if node.next if node.next, I guess you could say is not none. I don't know if you might be able to just implicitly say if node.next. And if it's the opposite of none, it'll be true. If it's none, it should be false. But we'll just say if it's not none, then go ahead and set the values here. And then now that you've set it, if next is none, then break. I don't know if that's gonna fix the issue that we have going on here. Again, the output is 4, 9. So weird. but it still passes for the next one. So it's 451. I'm sure there's something super obvious that I'm missing, but we'll figure it out. So 4519, and then I'm saying 459 because the input's 1. So 4 and 5, we're getting rid of 1. We're essentially taking 9 and putting it in 1's place. So then if 5 was pointing to 1, now 5 points to 9, which should be good. I guess the tricky thing here is like in the case where it's the second node, I gotta take this back brace off. Back brace really hurts. I mean, really, yeah, it really hurts. Really helps until it doesn't. I have a shoulder problem. So like in order to fix my back, I have to put the thing on, or it helps anyways, but then it messes up my shoulder. So it's like I'm trading one thing for the next. Okay, we'll just try and have good posture. Alrighty, so let's check our timer here. We're about halfway done. We got plenty of time. I don't, yeah, we're spinning our wheels a little bit, but I think if we ask some good questions and do a little bit of debugging, we should be able to figure out what in the world is going on. What does the diff do? I don't know. I'll find out. Test case, source mode. Sure. What the 45195. Yeah, interesting. Okay. All right. So input 4519. This is the entire list, that what they're calling head. This is the node, the 5. List node val of 5. And then, you know what we could do? This is interesting. We printed the node up top. Why don't we, now that we've like made the change, right? So we'll say before, and then let's like after we've done these mutations, let's say after. And then this, that's in the break. The break may not necessarily happen. So let's take it out here. So basically like, while it's not none, do the things, and then this is just our break case. See what type of output we get. Okay, here we go. So this is interesting. We have before, after, before, after. So on this first one, it loops 2 times. So if it starts at 5, and then the 5 becomes 1, and so then when it loops to, oh, this is interesting. Maybe this is part of our problem. Is the way that we're looping. We're just assuming that like, oh, it goes to the next one. And when there's only 2, that like when it's the second to last one, I think maybe this one only iterates 1 time, and then it breaks. Iterates once. Node.next is none, and then, oh, by the way, I think if you're saying is not none, then you could probably just break down here, and this would probably have the same output. You'd probably have to do an else, since there's no return statement. And then this, oh gosh. Normally, yeah, it does have my keyboard shortcuts. I'm on Windows now, so keyboard shortcuts are a little wonky for me, having just switched back from a Mac. All right, so this one says before, after, before, after, before. That's useful. Let's go look at case 2, before, after, before. So this changes. I think it's the only thing that's changing is that it's like, instead of having that additional check at the bottom where it just says we're done, it loops 1 more time, and then it finds out, oh, it is none, and then so it's already printed, so that's fine. And so I think if you wanted the same output that we had before, this is frustrating. Okay, it was working a second ago. Now we can look at it and see. This one does it once, this one does it twice. Okay, so when the node.next is not none, it's going to print the node before any mutations, and then it's going to print it after. So currently, the very first iteration, this is what the node looks like. It's got 5, it's got 1, it's got 9. And then after we've done our mutations, it's 1 pointing to 9. And then the node here, here's the problem, is we're iterating over the same node. So I mentioned recursion earlier. I think we probably have to do this recursively on node.next rather than iteration. And there's probably a way to do it iteratively too. But my brain like naturally is thinking recursion might be a more obvious solution here. So we have the operations. Let's go ahead and get this stuff out of here. So we have our like where we say, hey, the current value is equal to the value of the next, and then blah blah blah. So what if we did a self dot delete node? Basically, they say don't return, or don't return anything. We could just return none, just to break out of it. But basically, we could say if node.next is none, then return none, or something like that. Otherwise, self.delete none, not node, but node.next. So it takes a node, we're passing a node.next, which is another node, assuming that node.next is not none. And then it says, okay, well, your value is equal to the value of the next one, and the next is equal to the node of the next one. This might work. It's so weird. I had keyboard shortcuts a second ago. So frustrating. All right. I don't know if Python's going to like it like that, so we're just going to manually format these real quick and run this and just see what in the world happens. It doesn't like my indentation. What am I doing here? Yes, sorry. I'm an idiot. This logic needs to happen, I believe, here. I could be wrong about that. We might need to put it, usually the base case happens first. Basically, we're saying like, hey, if node.next is none, then we're done. Otherwise, it's go ahead and start doing the operations. And then once you're done with the operations, go ahead and call delete none again. We call it on self, and pass in node.next so that we can go to the next node in our linked list. So assuming that we have that correct, we should get past that error message. It's not called delete none. I have a typo. Thank God for good error messages. We're getting there. We're getting close. All right, object has no value next. Interesting. No dot, and this might be on the second iteration. So here we go, 5, 1, 9. After 1, 9, it takes in 1, 9, and then after, is this doing this? I feel like this is doing the same thing that our iterative loop did. No, it shouldn't though. Like before, this is the new node, and then after, oh gosh, none type object has no attribute next if node.next is none. Has no attribute next. Oh, okay. Sorry. If node is none, because we could potentially be passing none in, since we're calling self dot delete node with node.next. If we just set node.next equal to node.next.next and node.next.next is none, then we passed in none, which is a none type. So we're saying if it's none, then we're done. It's at this point, come on. It's solving algorithms that you're like really hoping that one eventually your click of none is just gonna be like, you did it, you figured it out. Obviously, we've got some things to hash out here. So we definitely could be keeping better track of what we're doing if we were to write more pseudocode instead of just like me thinking out loud. It might be good to put some of these thoughts on paper. But here it's saying that none type, again, it's a none object, has no attribute val. So I was saying like, hey, if node is none, then return none. But somehow it's still calling .val on a none, which is weird. This makes me want to move this up on this particular one, because if we look, it's like before, blah, 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 blah. If I run it, I want to see, is one of these none? And it's calling objects. Okay, gotcha. So here's what's happening, is that node.val appears to be, so let's just do this. Lots of print statements. We'll say node.val, and just to be more obvious about what things are, I like put them in all caps just so it's easier to find them in the print and output. And then we do something like node.next, node.next. And we should be able to see probably one of the node.next will be none, and we're trying to call val on none, and that's where it's getting the error message. Sure enough, the first one is 5, and then here it is 1 to 9, and the second one is 9, and then node.next is none. I don't know what I just clicked on. Some weird feature of Microsoft Edge. Okay, so we're saying, hey, if node is none, then return none. But let's go ahead and say, if node is none and node.next, oh, not and, or node.next is none. And I don't know if that's right. I'm actually going to think more about it, but just for the sake of like a little Hail Mary, I'll click run. Okay, it doesn't like that. Oh, sorry. Python, not JavaScript. Don't want to use the pipe syntax. Celebrate. I probably don't want to celebrate like that in an interview. Keep it professional. Keep it professional. Okay, so we've got a lot of print statements here. We've got a lot of, we've got some assertions about what we think should happen, and then we've got some kind of spaghetti stuff going on here. Let's clean it up, and then let's comment it out, and let's walk through it step by step. So we don't need all that. So basically, what we're saying is, check if node is none, node or node.next are none. To break, we'll just say as a base case. And then we'll say, otherwise, assign node.val to node.next.val, and then assign node.next to node.next.next, and then call, we don't have to explicitly say self, but we can say call delete node recursively, I'm not spelling that right, recursively passing in node.next. All right. So this is, the pseudocode is pretty close to what the actual code is doing. That's kind of the nice thing about Python though, right? Languages like Python and Ruby, the code that you're writing almost tells you exactly what it does, which is pretty ideal. It's easy to go back and read your own code and other people's code in the future and know, okay, this is exactly what it's doing, unless someone uses like a single character or like a very succinct variable name or does something like that. But okay, so delete node gets called. They pass in the node that they want us to remove from the linked list. We say, hey, we're going to do this recursively. We're going to keep calling delete node until the node itself is none or node.next is none. And we might be able to optimize this. We'll look at that more in a second. But if that's the case, then just return none. It says somewhere in here that I expected, here it is right here. The return type is void. You don't have to return anything. We're only returning none because we need to stop the recursive call of our function and start popping the function calls off the stack. So this is the meat of these two lines. This is the meat of our algorithm here. How much time do we have left? 18 minutes. We're doing okay. Like 42 minutes. Pretty average. So we're saying, hey, the current node's value needs to point to the next node in line. But that has to happen recursively until you get to the very end. So that basically you're just, I don't know if bubbling up is the right word, but you're taking the current node and replacing it with the node to its right. Now the node to its right needs to be replaced with the node to its right and to its right and to its right until there are no more nodes to point to, at which point you just want to make sure that that very last node is pointing to none, which it should, because once the second to last node points to the last node is already pointing to none. And so I'm curious if we can get rid of this and just say if node.next is none. But the thing is, I think we do pass in none as a one of the values here at some point. Yeah, it doesn't like that. And then we have to have, that was like the thing that solved it. So yeah, I think we're good here. I don't think we can do it with just this either. No, we can't. Okay. So I want to walk through exactly what happens with this 4519 thing with our code. So we have 4519, and they say, hey, the node is 5. Okay, so the 5 node points to 1, and that points to 9, and that points to none. All right, the blue here is not very easy to see, so that's kind of annoying, but we'll blow things up a little bit so we can see it better. Okay, and so the 4 is already pointing to the rest of, the 519. So we're not worried about what comes before, we're just worried about what comes after, because this is a singly linked list. The node that we're currently working on is pointing unidirectionally to the right. Yeah, or whatever. There's no such thing as right or left, but just for the sake of visualization here, to the right. So we're saying, hey, 5 here has a val of 5, and it has a next of another node 1, but then that one has a val of 1 and a next of 9, and then that one has a val of 9 and a next of none. Okay, and so basically what happens is we start out with this one, and we say here your val is now equal to dot next's val. Okay, so your val is now 1, and then we say your next is equal to next's next. So your dot next is this one right here, and we want to point your current dot next to the dot next of your dot next. That's a lot of dot next, hard to follow, but we have 1, we have 2, we have 3. We're saying 1, you're pointing to 2, so now your dot next points to 3. You're taking the dot next from the middle one and you're assigning it to the one, the first one. And so now this becomes 9. Okay, now we don't need to deal with the 1,9 node because we've already taken it and assigned it to the 5,1 node. So 5,1 becomes 1,9, or 5 becomes 1. Now what we want to do is we want to go to the next one in line and make sure its dot next is none, because it's well, it doesn't have to be none, right? In this particular case, we want the next one, gosh, here, the one that is now 9, we want it to be, make sure that it's none. That's going to end it. If there is no end, if there was like a 6 after that or whatever, some other unique number, then we would just keep repeating this process until we got to the none, right? And so at this point, let's think about this. If 5 is now 1 and next is 9, then next, this next is actually none. So I think at this point, we're actually done. I could be wrong. We call it on node.next. So let's just do our output here. If node.val, which was 5, is now equal to node.next.val, then it's now equal to 1. And node.next, which was 1, is now equal to node.next.next, then it's 9. And now we call self.delete node on node.next. Well, node.next is 9. So we're calling this on 9. So val is equal to 9. Next is equal to none. The if statement here says, if the node is none, which it's not, right? The node is 9. Or node.next is none, then we're done. Okay. And so we are able to say we're done doing everything because the node.next is none. And so what we end up with here is 1 pointing to 9 and then 9 pointing to none. There's no more history of the 5 that was at the beginning. And then the 9 at the end is now in place of the 1, the 1's in place of the 5. So this technically should run once. I am a little curious about, let's see how many times it runs. Running with a G at the end. I'm so hot in here, it's insane. Oh yeah, I've got all this. Let's get that out of there. If your interviewer lets you use like Excalidraw or something, some type of whiteboard, which they probably will, they'll probably send you one. In addition to writing out the code solution, that's great, because then you can do all this diagramming beforehand. And if you ever get stuck, you can just refer back to it and make sure that your understanding is in sync. So on this one, it says it's running twice, but I think that's because the first time it runs the code, and the second time it runs, it's none. On the second one, it's running twice as well. It's 1 this time. So if it's 1, it runs the first time. Now, if it's 1, its dot next is 9. Okay, so it still has a valid dot next, and the node itself is still valid. So then it points its val 1 to 9, and then 9, its val points to the value of the next one, which is 9. Its next points to 9's next, which is none. So now basically 1 and 9 just become 9. And so then when we call node.next, we're actually passing none to the recursive call. And so that's why we have to check and see if the node is none, because there's 2 different situations. If you're in the second to last node, then node.next is none. If you're anything 3rd, 4th, 5th, 6th to last, etc., then it's going to be the first case is what you're going to end up with to break out of it as a base case. Hopefully that's clear. Let me know in the comments if it's not. Give this one a try. I always say this at the end. I'll put this in the description if people read description before they watch a video, but pause the video, try this first, solve it on your own. Even if you get stuck, it's still helpful to like try and solve it, and then come through and watch my solution, and you can see what I did. 100% looks so small. Now that I've had it all zoomed in, I'm like tripping. Okay, stay focused. Let's run this. Looks like it's working. We'll go ahead and submit it. There may be additional test cases. Yep. What? So this is interesting. Test case. It only passed half of the test cases here. So this is something that can happen where like there'll be like 1 or 2 tests when you're just running it, but then it'll run the entire suite whenever it's doing the final submission. And so now it's saying that my solution is not correct. It's failing half of them. Let's look at the particular one that it's stopping at. It's saying input is 2013. Oh, this is interesting. Okay, our solution should have worked for this, but let's just see why it's not working. Our output is 03. Something's happening with the 1. And their expected output, of course, is 013. So if the input is the root node, then the first thing that we're saying, hey, is the node none? It's not. Node.next is not none. Node.next is 0. So it says, okay, node.val is equal to node.next.val. So 2 becomes 0. And then node.next is equal to next.next. So 2 becomes 0. 2's next becomes 0's next, which is 1. So basically 0 gets shifted to the left. And then we call delete node on node.next. Well, node.next now is 1. And so the next call says, hey, is node none? No, node is 1, right? 0 is now pointing to 1. We're looking at node.next, which is this 1 node. And node.next is none, it's not, it's 3. So then we say, okay, well, value is equal to node.next.val. So val is 1, next.val is 3. Okay, this is probably where our problem is. So let's think about this. Oh, you know what I'm realizing? I think after the initial assignment of val to node.next.val, we no longer have to update the value. After that, it's just a matter of changing next to the one to the right, right? So let's diagram this. Let's do an excalidraw.com, and it is, I know I've said this like 10 times already, it is so hot in here. It is definitely making solving this problem much more stressful. What might otherwise be a fairly simple problem to solve. All right, so we have, let's say 1, and I don't know, the first one was like 2, and then the next one, this is not pretty. I could be using these tools, but whatever. The next one, we'll just say is 3, and the next one is, we'll just say 9. And let's say we start with 2. So we want to set 2 to 1. But if we set 2 to 1, aren't we kind of done after that? That's something to think about there. If it's the first node, I don't think there's any way for us to know that it's the first node is the problem. But the tricky thing is like, okay, if we set 2, the val of 2 to 1, so that it's equal to 2 initially. Get this goofy looking font. And then next is 1. So we need 2's val to be node.next.val. Okay, 1. This needs to happen once. And then we need it to point to node.next.next. Okay, because currently next is pointing to 1. But now that val is 1, we need next to be node. We need it to be 3, which is node.next.next. Here's the thing though. If 2 is now 1 and next is 3, then 3 already points to 9 and 9 already points to none. So we're done, right? So in this situation, we would only need to point to it one time. Let me see here. Okay, let's do a different use case here where we have, let's go ahead and just put our number in here. We'll start with 1. All right, we'll start with 2, but the input value will be 1. So we'll see what that is. There's probably a duplicate key in here somewhere that makes it much easier to do this. What are our actions here? Is one of these duplicate? Yeah. That's probably one too many. All right, boop. Cool. Space these out a little bit. Get some arrows going, just so that we know. Oh, nice. Control D, perfect. All right, here's our linked list. Update these values. 3, 2, 1, 3, 9. Let's say our input is 1. And so we need 1 to become 3, and we need next to become 9. Now, if 1 is 3, which is next.val, and then next on 1 is 2 over, then the next of 9 is already none, right? That doesn't need to change. And we've essentially got, so I think we only have to do, wow, pretty naive with my initial, assuming that I'm right about this, my initial solution was kind of naive. So it seems like we only have to do one operation, and that is this. Do we even need recursion? I'm gonna feel real silly. Basically, it's just saying like, hey, point these over. This might mess us up if we're close to the end though. If this is a solution, I'm gonna be happy, but also annoyed. This whole time, I'm like, we need iteration, we need recursion. The reality is, you need 2 lines of code. Okay, so this was a medium problem apparently, way easier than I thought. I guess that is the downside of labeling these as easy or hard, because then I went into it thinking like, this is more difficult than some of the easy ones. That probably requires a really difficult answer or complex answer. If we had diagrammed ahead of time, I think I did like initially I probably did like, oh, whatever. But if we had diagrammed ahead of time in Excalidraw or on a piece of paper or whatever, we would have realized much more quickly like, oh, you only need 2 operations and then you're done. Let's look at the I thought I was on NeetCode. This is what is this place called? LeetCode. Okay, so assuming that's our solution, I think I already submitted it. Runtime in memory, apparently it's super fast. Great. I'd love to hear that. Let's look at the solutions. In Python 3, I don't really care about any of these other ones. 2-line solution. Val is equal to node x val, node x equal to node x. Yeah, that's what we did. Anybody else do anything different? Nope. Same. Very easy. Is easy. Step-by-step explanation. Same thing. These are all the same. Alrighty, Cool. Well, how are we doing on time? Ah, there it is. 0 seconds. All right. So, I was super excited earlier whenever I thought that I had solved it, right? I ran and those two test cases passed, and I was like, yay. Um, yeah, somehow I convinced myself that this solution required recursion because I was thinking like, oh, if you update the current one that you want to get rid of to the next one, then you have to keep doing that. And without like visualizing it, which I did with Excalidraw later, once we ran into additional test failures. So I always like to recap and think about lessons that I've learned while solving these problems on LeetCode or NeetCode or wherever else, Code Wars, etc. And in this particular instance, I would say it wasn't so much that I didn't fully understand the problem. I mean, that was definitely part of it, and that's what usually gets me is when like I try to solve it too quickly. And in this case, I think I definitely committed to multiple solutions, first iteration and then recursion, because my brain was like, that's the right path to go down. So in the future, if I'm allowed to whiteboard, which I think in most cases you should be able to, definitely take advantage of that. In the before you ever touch a line of code, while you're still reasoning about the solution and you're like trying to visualize everything, diagram it out and say, okay, this is a potential input and this is the potential output, and these are the steps that are required. And then once you do these processes, then this is what happens. So I do these two operations. This is the outcome. Oh, I'm done. Okay, let's try it in a different situation where it's not the first node, it's the second, or maybe it's the third. We know it'll never be the last one just based on what they told us. If I had done that, then I would have realized very quickly, maybe not in an hour's time, that this is a 2-line solution. So thank you for hanging out with me while we solve this one. I'm going to crack my AC on now and can cool off. We'll catch you all in the next one. Let me know in the comments if you have any questions or if you have any suggestions for next videos. Appreciate it.